V0 by Vercel has amazing generative UI capabilities. Simply tell it what you want to create and iteratively build the complete UI of your app. Combine it with BuildShip's AI-generated backend APIs to get a full-stack app. Welcome to the era of generative full-stack apps. Let's play a quick game of Guess the Prompt. Okay, so you've probably never heard of this game before, but the way it works is that on the left-hand side, we have an image that was generated with AI using a particular prompt. And on the right-hand side, what we need to do is try to guess the prompt that was used to generate this image. Pretty simple, right? So let's give it a try. Here I'll enter fireflies in the forest. We'll submit. And now the game will generate a score based on the prompt we enter. And so you can see at the bottom here, we got a similarity score of 57.69%. On the left-hand side here, we have our original image with the original prompt that was used to generate this image. And on the right-hand side, we have our guess that we entered. So we were somewhat close with our guess. But let's try again. We'll click play again, and this time we get a new image. So this looks like a jellyfish. We'll submit. Again, we're going to generate a score based on the prompt we entered. Great. On the left-hand side, we can see the original prompt that was used to generate this image. A glowing jellyfish dance in the dark waters, etc. Meanwhile, on the right-hand side, we can see the guess we entered. In this case, we simply entered jellyfish. And this time, we got an even lower similarity score. And that's the core of our game logic. The closer your guess prompt is to the original prompt, the higher your similarity score will be. But what does it actually look like to build a game like this from scratch? Granted, the gameplay of this game is pretty basic, but you're probably still thinking to yourself that you need to write a lot of code to get something like this up and running. You're probably thinking that you need to code this UI interface, the gameplay interface, and you're probably already feeling discouraged. But wait, there's a second part to this as well, right? With the game logic itself. And where does that live? That lives in an API. So you're probably thinking to yourself that now you have to code the front end of this game, but you also need to know how to code the game logic itself. So there's the front end that requires coding, and then there's the back end where your game logic lives that also requires coding. But what if I told you that that isn't necessarily true anymore? At least for this game here. What if I told you that we wrote almost little to no code for this game? And how did we do that? Well, by using the power of AI, of course. If you don't believe us, then you need to make sure you stick true to the end of this video so you can witness it for yourself, because we're going to be building this exact game here from scratch. Before we begin, let's briefly talk about the two tools that we will be using to build this game. The first one is V0. This is a service from Vercel that allows you to generate entire front-end components given a prompt. For example, here you can see a prompt, a login responsive and modern. And here you can see that the AI generated the login form completely. Like, how amazing is that? Just think about it for a second. For even such a simple component like a login form, you'd still need to write a significant amount of code. Don't believe me? Let's take a look at the underlying code that was generated for this component. So we'll go to code, and here you can see the code that was generated by the AI for this login component. And this is just one of the many examples that they have. If we go to their landing page, you can see that there's a bunch of examples here that you can use for inspiration. For instance, here we have another UI component that was generated given a prompt, a carousel of images, use just HTML and CSS, no use of Tailwind. And you can see that the AI was able to generate this carousel component. And the great thing about V0 is that not only does it allow you to generate amazing UI components just using a prompt, but it also gives you different variations that you can choose from. Now, later on in this video, we'll see how we can take the UI we generate in V0 and use it in our own project. So we will use V0 to generate the interface for our game. But what about our game logic? Well, this is where BuildShip comes into play. BuildShip is a low-code visual backend builder that you can use to create powerful and scalable backend logic. And the great thing about BuildShip is that we'll be able to build our entire game logic in a visual manner. This will make it super simple for us to build out our game logic without having to write a single line of code. If we ever come to a point where we want to extend or modify the gameplay, then we don't have to worry about writing any code to do that, because we can just use BuildShip's Generate with AI feature to easily get that done. While this is a low-code tutorial, it's important that we mention that we will still be writing a small amount of code. V0 does a great job at generating UIs based on a given prompt, but it's not necessarily perfect yet. And sometimes, as will be the case in this video, some human input is still required. But don't worry, because we'll be explaining each part as we go on. And with that out of the way, we're now ready to begin. First, we'll start by building the UI of our game, and then later on, we'll hop over to BuildShip to go through the game logic. And of course, for the UI, we will be using V0. While V0 does a great job at generating UI components from a prompt, we found that it does an even better job with generating UI components given an image instead. So what we've went ahead and done is created some mockups of the UI screens that our game will have. So here we have our initial screen, then we have the guess the prompt screen or generating score screen. And then thirdly, here we have a similarity score screen, and that's about it. So in V0, the first thing we'll do is upload an image, and we want to start generating our initial screen. So we'll upload that image. And now instead of using a prompt, V0 will instead use the uploaded image to generate our UI. So let's hit enter, and V0 is now generating our UI. So now we just have to wait for it to complete. Okay, so after a few seconds, we can see that we get back a few variations that we can choose from. So this is the first one, and this is the second one, and then this is the third one. Now, if we go back to our original image that we uploaded, we can see that this game screen layout has a 2-column layout. On the left-hand side, we have the generated image, and on the right-hand side, we have our prompt input. And at the top, we have our game title centered. And so option B is the closest, but we can still make it better. We can edit this generated screen by entering a new prompt. And this time we're entering a prompt. Please make sure the top text is full width and centered. And then under that, make sure the image is on the left and the input and submit is on the right. We'll enter this prompt. Beautiful. And this is exactly what we want. And just like that, we've generated the first screen of our game. Now, before we start generating the other screens, let's get this screen running locally on our computer. And in order to do that, we'll need to set up a new Next.js project on our computer. Now, if you're unfamiliar with what Next.js is, it's a framework for building front-end applications. So the way this will work is that we will go to V0 and we'll go to code and we'll copy this command here. And in our Next.js project, we will run this command. And then what will happen is that all of this code will be injected in our application, and we can just run it right away without having to write a single line of code. So let's start by setting up our Next.js project. We'll go to get started, and then we'll go to the installation section. And from here, what you want to do is copy this command. Next, I'll bring up my terminal and navigate to my desktop. And here I'll just paste the command. Hit enter to proceed. Next, we need to enter a project name. So we'll enter guess the prompt game. Would you like to use TypeScript? For now, we can just select the defaults. ESLint, Tailwind CSS. Would you like to use the source directory? Again, we'll just select the default. Would you like to use app router? We'll select the default. It's not important for you to understand what each of these mean. These are merely the options we need to fill out when creating a new Next.js project. So this will create our project. And now that our project has been created, we can change into that directory. And we can now run our application by entering the command npm run dev. So this is running on localhost 3000, so we can copy this URL and open it in our browser. And here we have our brand new Next.js project running without any problems. Great. Now let's open up our project in our code editor. I'll use VS Code, but you can use any code editor of your choice. We'll go to desktop and guess the prompt game. And now we're ready to inject our first screen into our project. So we'll go back to V0 and we'll now copy this command. We'll go back to our project, and in the terminal here, we'll paste the command and we'll run it. We can just go with the defaults, just hit enter, and you can see it's giving us a warning here. So what we need to do is just copy this command and run it. Just hit enter again. Great, so our configuration is now set up. So we can go back to V0 and copy this command again so that we can add this component to our project. We'll just paste it again in the terminal and we'll hit enter. And this time it's asking us what should we call our component. So this time I'll just call it the initial screen. We'll hit enter, and now it will inject our component that we generated in V0, and we can see that it is completed. So if we go to our components folder here, you can see now that we have our initial screen component. If we open this up, we can see that the code here is the exact code that we generated in V0. Beautiful. So if we go back to our Next.js project, we can see that we're getting an error here. So what we'll do is go back to our terminal where we run our project, and we'll end this current run and we'll restart the development server. Now we'll just refresh our application. And we can see that the error went away, but we're still not seeing our screen that we're expecting to see. That is this guess the prompt screen that we generated. So we'll go back to our project, and in order to see our screen, what we'll need to do here is first clean the house a bit. So we'll go to the entry point of our application under app. We have this page component. So there's a bunch of code in here that we no longer need. So what we'll do is we'll just delete all of this boilerplate code. And now we'll save. So what we want to do now is render our initial screen component. So to do that, what we'll do is we'll just copy this name here, and we'll go back to our page component and we'll paste this name. But in order to render this component in our application, we need to surround it in some arrow brackets. So we'll first have a opening arrow bracket, and then a forward slash and closing arrow bracket. And then we're getting an error here because we need to import this screen from our components directory. So we'll just import that screen. And now if we save our changes and go back to our application, we can see now that our initial screen is being rendered in our app. How awesome is that? We still have some work to do in this screen. For instance, we need to display the random generated AI image, and then we also need to handle the guest prompt that the user submits. And of course, we're going to be doing all this game logic in BuildShip, but before we do that, let's generate our other UI screens and inject them into our project. And so back in V0, we'll go to new generation. And just as we did it before, we'll upload an image, and then the image here will be our second screen. We'll upload it and we'll hit enter. Remember, the second screen here is kind of like our loading screen while our score is being generated. So this is another 2-column layout here. On the left-hand side, we just have the original image. And on the right-hand side, we have a placeholder image with a loading indicator. So if we take a look at the results that we get from V0, we can see that we get back a couple of variations, and it seems the closest one is option C. Now, the only thing that's off here is the width of the column. So you can see on the left side, this column is much larger than the column on the right-hand side. And we would prefer to have both of the columns be of the same width. So to do that, we'll edit our generation by passing a new prompt. Please make sure the image on the left and the placeholder on the right have the same column width. And we'll hit enter. Beautiful. Now this is precisely what we want. And just like that, we've generated our second screen. Now let's move this screen into our project. So if you remember, to do that, we need to go to code, and then we'll copy this command here. We'll go back to our project, and in the terminal, we'll paste the command. And we simply need to run this command to inject the loading screen into our project. So here it's asking what should we call the component. I'll call it loading screen. and we'll hit enter and it's done. So if we go to components, we now have a new loading screen component here. And if we open this up again, you'll see that the code here is the exact same code that the AI generated for us. But if we go back to our application that's currently running, nothing changes. So we need to actually render this screen in our application for we to actually be able to see it. So to do that, we'll just go back to our page component. Remember, this is the entry point of our application. And now what we want to do is render our loading screen here, very much the same way as we did with initial screen. But before we do that, we'll just surround the initial screen component with some arrow brackets, some opening and closing arrow brackets, that is. And we'll cut this from here and paste it in between these brackets. And now we can copy this initial screen component and just paste it again. And then instead of rendering initial screen, what I'll do is just delete that. And now we want to render loading screen. So we'll just do loading screen. And my code editor supports auto imports, so we can just hit enter and it will import our loading screen at the top. Let's just temporarily comment out our initial screen because right now we only want to see our loading screen. So we'll comment that out temporarily, we'll save. And if we go back to our application and refresh, you can see that we have now injected our loading screen and it's looking great. And now we have all but one more screen that's left for us to generate. And this is of course our result screen. And this is where our similarity score will be rendered out, as well as our original prompt on the left. And on the right hand side, we'll have our guess and an image generated for our guess prompt as well. Okay, so now we will just repeat the same steps as before. We'll go to new generation. And from here, we'll upload an image. And the image we want to upload is our score screen. From here, all we'll do is just hit enter and wait for V0 to generate our UI. Okay, so it's in the process of generating our UI. So let's see what we get back. Very nice. I actually think in this case, this is very close to what we want. So we can just go with option A for now. On the left-hand side, we have our original prompt. And on the right-hand side, we have our guest. At the bottom, we have a similarity score and we have some optional action buttons. Now let's add this screen to our app. We'll go to code and just as before, we'll copy this command. Let's go back to our project and we'll paste this command here and we'll run it. Now we're prompted to enter a name for our component. So we're just going to call this score screen. We'll hit enter. And if we go to components, we'll see that we have a new UI component called score screen. So we'll go back to the entry point of our application, page.tsx. We'll temporarily copy the loading screen, paste it, and instead of loading screen, we'll enter score screen, and we'll just import that screen at the top. And now let's just, for the meantime, comment out loading screen so that we can just see our score screen. We'll hit save. Now if we go back to our application, we can see that we are getting our score screen rendered out and it looks precisely the same as it does in V0. Great. And with that, we've now generated all our screens without writing a single line of code. And we've also added those over to our application. So if we go back to our project, let's comment out the score screen and let's just uncomment the initial screen and let's start working on our game logic in BuildShip. I'll save this file. When we go back to our project, we can see now that we're back to our initial screen. So let's think a bit about how this screen will work. The first time we load this page, we expect an image to be displayed here. Now this will be an AI generated image. And the next thing we expect to happen is that when the user enters a prompt and hits submit, we need to calculate their score. Now here we are in BuildShip and we'll start by creating a brand new workflow. And we'll give this workflow a name. We'll call it get random image and we'll create it. And next we'll need to select a trigger for our workflow. So we'll add a trigger. And for this demo, we want to use the REST API called trigger. So our front-end application will call our BuildShip workflow via this REST API endpoint to retrieve the AI generated image. So here we just need to specify the path. We'll say get random image. And we can leave the HTTP method to get. Okay, so the next thing we want to do is generate a random scene. Essentially, we want to generate some text that describes a scene using GPT. And then using that description, we will generate an image. So let's go to add a new node here, and we'll add the text generator node. So the first thing we need to select here is our OpenAI API key. So we'll go to secrets and we'll just select that. Of course, if you don't have one, then you can easily create one by going to add secret. Next, for the user prompt, we're just going to pass a hard-coded prompt, which is instructing GPT to describe a unique scene in one sentence. Now we can paste the same thing for our system prompt here. And now the last thing we'll change here is our model. We want to use GPT-4 Turbo. So using this text generator node, GPT-4 will generate a random scene for us. So the next thing that we need to do is generate an image based on this scene. So we'll go to the OpenAI group and we'll add a node called image generator. We need to select our OpenAI API key again. And then for the model we want to use the latest one, which is DALL-E 3. And then for the input text, which will dictate which image we want to generate, we want to use the output of the text generator node, and this is looking good. Our image generator node will return an image in base64 format. So next, what we'll need to do is upload this image for persistent storage to the cloud storage bucket that comes with every BuildShip project. Let's do that. We'll add a new node and we'll just search for base64 and we'll select the upload base64 file node. And here we just need to enter the base64 file we want to upload, which is of course the output value of the image generator node. And then for the file name, well, we want to assign a unique file name to our image because we don't want to override any existing files. For the unique file name, we'll just use the current timestamp. So to do that, we'll switch to JavaScript, and then in a pair of backticks, we'll say date.now, which will give us the current timestamp. Next, we just need to specify the extension, which will be a .png file. And the last thing to do in this workflow is to just return some values back to our client. But what values exactly? Well, if we go back to our finished game, we need to return, of course, the image that we generated. So we will return the image URL. And what we also want to return is some hints to the user. And then finally, what we want to return is the prompt that we generate using our GPT text generator node. So to begin, we'll go back to our workflow and we'll add a return node. So we'll just search for return. We'll select it. And then for the value we want to return, this will be a JSON object. We'll switch to JavaScript here. And so we want to return the prompt, image URL, and hints. So for the prompt, we're just going to get the value returned from the text generator node. And for the image URL, we will use the value returned from our image generator node. And to return the hints, we will use a regex. So basically what this regex is saying that for the prompt that we generate, we want to extract all the words in the prompt, and then we want to shuffle them, and then we want to select 3 of them. So if we go back to our game, you can see at most we will receive 3 hints. Let's test if our workflow is working. But before we do that, we'll need to ship our workflow. And now that our workflow is shipped, we can put it to the test. So we'll go to test. And because our workflow doesn't expect any query parameters or body parameters, we can just test the workflow. So after a few seconds, we can see that the test was successful. And we can take a look at the output that our workflow emits. And we can see the first thing here is our prompt. The second thing here is our image URL. So we can preview this image URL. We'll open it in a new tab. Beautiful. And then we get an array of hints. Awesome. So our workflow is working fine. And now for the big question. How do we connect our app with our BuildShip workflow? And more importantly, how can we do it without having to write much code? Well, that's pretty easy because we can just use ChatGPT to generate the code for us. All we need to do is provide a detailed enough prompt and ChatGPT will do the hard work for us. So let's head over to ChatGPT. and we'll enter a prompt. And so here is our prompt. I have these two components, and what I want to do is when the page first loads, make a GET request to an API endpoint that returns a JSON of image URL and a hints array. And in the initial screen component, show this image on the left where the current placeholder is, and then show the hints above the submit button. And so what we'll do is we'll copy our code. First, we'll start with our page. We'll paste that here, and then we'll grab the code for our initial screen and paste that here, and then we can submit our prompt. So immediately ChatGPT is starting to give us results, and we can see that it's also generating the code for us. First, for our initial screen. Okay, so we can see that ChatGPT has generated some code for us for our initial screen. And you can see here that we're making a fetch request, and then we're parsing the response, and then we are basically extracting the image URL and hints from the response. And we're using the image URL here, so we're basically displaying that. And then we're displaying the hints as well. But what we'd prefer to do is do this data fetching in our page component, which is the entry point of our application. So we can just tell ChatGPT to do that for us. So here we're entering a new prompt. I prefer to fetch the data in the home component instead. Okay, so ChatGPT will now generate our new code for us. And we can see that it's moved the data fetching to our home component. And so it's generating the code for our home component here. And if we scroll down, we can see that it's also giving us the code for our initial screen. So let's put this to the test. We can just copy the code for the home component, and we're going to go to our page and just paste it here. Okay. And then next we will go to the code for the initial screen. We'll copy it, and then we'll paste it in our initial screen component. We'll save. Now if we go back to our application, we're getting an error. So let's refresh to see if the error persists, and it still does. So let's read what this error is saying. You're importing a component that needs use effect. It only works in a client component. And so if we want to do this, we need to copy this code, use client, and paste it in our page component at the very top. Okay, so let's save the file. And if we go back, we can see that our application is back working, but we're not seeing our image yet. So what we want to do is head over back to BuildShip and copy this workflow URL. To do that, we'll go here and we'll copy, and then we'll go back to our page component. And then here where it says your API endpoint, we'll paste our workflow endpoint. Great. So let's go back to our application now, and we should be making a request to our workflow whenever this page is reloaded. So let's just wait for a sec while it's fetching the image to see if this is working. And would you look at that? We are actually getting the image from our workflow. One thing that is looking weird here is how hints being rendered line by line. Instead, what we prefer to do is have them comma separated. So we'll go back to ChatGPT and change that. And here we'll enter a new prompt, just make the hints be comma separated instead. And then we'll enter. Okay, so ChatGPT has generated our revised code. So we'll copy this new bit here, and we'll go back to our initial screen. We'll paste it here. And then if we scroll down, we can see that we are using it here. So we'll just copy this code, and we'll paste it above our submit button. We'll paste that code. When we go back to our application, we can see that now we're getting our hints displayed the way we want. And now we can go back to our code and remove the old one. So let's do that. We'll just delete this, and we save our code, and we go back, and perfect. This is precisely what we want. The next part to handle here is when the user submits their guest prompt. So when the user does this, we will be submitting a request to a new BuildShip workflow that will calculate the similarity score based on the original prompt and the submitted guest prompt. So let's start working on that workflow. Let's create a new workflow. and let's name it calculate score. We'll need to select a trigger for our workflow. Again, we will be using the REST API called trigger, but this time we want to change the method to a post request, and the path we'll set to get score. Ultimately, what we want to do in this workflow is calculate the similarity score for the prompt the user submits. But before we do that, we want to generate an image based on the prompt the user submits. So we're doing this because if you recall in our score screen, on the left-hand side, we have the original prompt and the image. And on the right-hand side, we have the user guess along with the image for their guess. So let's do that. We'll add the same OpenAI image generator node that we previously used. We'll select our API key, and the model we want to use is DALL-E 3. Now for the input text, this will be the value our user submits, which is the prompt they guessed. So we're going to extract this value from the request body, and we're going to be sending this value in a guessed prompt field. Great. And if you remember, this node will return the image in base64 format. So we'll upload this image to our cloud storage bucket. To do that, we'll add a new node. We'll search for base64, and we'll select the upload base64 file node here. The file we want to upload is the value returned from the image generator node. And then again, we want to use a unique file name here. So we'll just use the current timestamp again, and we'll add a .png extension. And now we're ready to calculate the similarity score. And to do this, we'll be using an algorithm called the Jaro-Winkler distance algorithm. Hopefully I pronounced that properly. So essentially, this is an algorithm that we can use to measure the similarity between two given strings or texts. So for example, text 1 here, we're using Elon Musk. And for text 2, we're passing : Musk. If we compare this, you can see that we get a similarity score of 85.50%. So essentially, anything that is above 80% is considered a match. Anything below isn't. BuildShip provides a utility node for calculating the similarity score between two given texts using this algorithm. Let's add this node, and we'll search for calculate, and we'll select the calculate similarity score node. And now we just need to fill out these values. So text 1 will be our original prompt. So let's add this. This value will be coming from the request body as well. And we'll get this value from a field called original prompt. And text 2 will be the guessed prompt the user submits. So again, we're going to be extracting that value from the request body. Great. And so if we go to the output of this node, we can see that it will return a number, which is the similarity score that's been calculated. And now the last thing to do in this workflow is to return the generated image and calculated score. To do that, we'll add a return node, and we'll set the status code to OK. And then the value we want to return will be a JSON object. The first field here is for the generated image, and we'll get this value from the upload base64 file. So this will return the download URL of the image. And then for the score, we'll get this value from the calculate similarity score. And that's all there is to our calculate score workflow. And before we can test that everything is working, we'll ship our workflow. And with that finished, we'll go to test. And this time our workflow is expecting to fill the original prompt and the guessed prompt. So we need to fill in these values. We'll go to the body tab. We'll fill out these two values. First, for the original prompt, we'll enter a man walking down the road. And for the guessed prompt, we'll enter a woman walking down the road. Let's test the workflow, and it works. As you can see, we got about two values. The first one is the generated image, and the second one is our calculated score, which is about 86%. And of course, we can preview our generated image for the guest prompt to see that it's working. Yeah, we do get back a woman walking down the road. Now we need to wire our app with our newly created workflow. So whenever we enter a guess here and hit submit, We want to call our BuildShip workflow to calculate the similarity score. And then while that's generating, we want to show our loading screen. And after our similarity score calculation is complete, we will show the score screen. So let's see how we can do this step by step. Of course, we want to avoid having to write any code for this, so we'll have ChatGPT generate it for us instead. So here we're using a different prompt. And we're telling ChatGPT, now in the initial screen, when a user enters a value in the text area and hits the submit button, we need to make a post request to another API endpoint. Remember to handle this request on the home component. And this endpoint will return this JSON. While we're making this request, we should display the loading screen with the image from the initial request. So now all we need to do here is pass some context to ChatGPT. And we'll go back to our project and we'll copy the code for our home component and we'll paste it here. Then we'll do the same for the initial screen. And then lastly, we'll do the same for our loading screen. And we'll hit enter. Okay, great. So ChatGPT has generated the code for us. Now we just need to verify that this actually works, right? So let's copy this code over to our project and then we'll go over it to see if it makes sense. So first we'll copy the home component and we'll just paste it back in our page component. And let's scroll down. And then this is the code for the initial screen. We'll copy this code and paste it in our initial screen component. And after that, there isn't any more code for us to use. So let's head over back to our project and we've saved both of these files. So if we go back to our application, let's refresh. Whoops, we need to add use client back to our page component. So we'll add that back at the very top of the file. We'll save. We'll go back to our application. Well, look at that. ChatGPT broke our app. But that's okay, because we can just revert our changes. And now it should be back to how it was before. Great, it's back working. And this time we can try again, but using a more detailed prompt. So let's do that. Back again in ChatGPT, I've went ahead and entered in a more detailed prompt. And I've also pasted our code for additional context. We'll submit this. But unfortunately, ChatGPT is having a hard time generating the code we want. And this brings us back to one of the initial points I made at the beginning of the video. Remember when I said that AI does an almost perfect, but not perfect yet job of generating code? And remember when I also said that moments may arise where some level of human input is still required. And this is a perfect example of just that. So we'll need to add the code ourselves for this to actually work. Okay, so I went ahead and added some changes to our code to get our app working the way we expect. Let us go through these changes. First, let's start with our initial screen. So this is the screen here. And remember, we have a input field for the user to enter their guess. Okay, so when they click on the submit button, we will call a function called handle submit. And this handle submit function is being passed from our page component to this initial screen component. If we go back to our page component, you can see that we have a function called handle submit. So here we are passing this to our initial screen. And in this function, we are making a post request, or this is where we should be making a post request to our calculate score workflow. So let's go back to that workflow in BuildShip, the calculate score workflow, and we'll copy the endpoint URL and we'll paste this here. And so we're making a post request to this workflow here, and we're passing the guest prompt the user submitted as well as the original prompt. And when we get back the score, we're keeping track of it as well. And while we're calculating the score, we have a generating Boolean variable that we use to keep track while the score is being calculated. While the score is being calculated, we want to display the loading screen. Now in the loading screen, we're also passing the original image. So we go back to our app, it would be this image here. So this will only be displayed when we're generating the score. And if we're not generating the score, then we'll just show our initial screen. So let's test if this is actually working. We'll go back to our app and we'll enter a guess here. I'll just enter a tree and we'll submit. And you can see that now it's working. We get our loading screen. And if we wait a while, it should disappear and we should get back our initial screen once the calculation is completed. And as you can see, we do get back our initial screen. Great, this is progress. Okay, so we're almost finished with our game. But when we submit a guess, we don't want to be redirected back to the initial screen. Instead, after our similarity score is finished being calculated, we want to display the score screen instead. So let's see how we can do that. And while we can trial and error with ChatGPT and try to have it generate the code for us, instead, we'll save some time and I'll add the code. And then we're going to go through each piece so that you understand exactly what it's doing. Back to our code, we went ahead and added some new functionality here so that we can display the score screen. So let's go through this step by step. Okay. So this is our loading screen, and when the user enters the prompts and hits submit, we already have that functionality handled. So if you recall, we added this handle submit function that makes a post request to our get score workflow. And at the end, this workflow returns the generated image as well as our calculated score. So when this function is first called, we set generating to true. And in this case, if generating is set to true, we're going to display our loading screen. And after the loading is completed, we set generating to false. So our loading screen will no longer be displayed. But one new piece of code that we added here was that whenever we get a response back from the request, we are storing the response in a guess score state. So if we scroll down back to our code, if guess scored is defined, which it should be if we successfully calculated the similarity score, then we want to display our score screen. And note how we're passing the guess score, we're passing our original guess, and the prompt the user entered. So let's go back to our score screen. And the first time this screen is loaded, because we get back our similarity score in decimals, we want to convert it to a whole number so that we can display it as a percentage. So that's what we're doing here. And then if we scroll along to the bottom, you can see that under the Your Guess section, we are now displaying the user prompt. And just above that, we are displaying the generated image relative to the prompt the user guessed. And even before that, we're displaying the original image. And so one thing that I forgot to add here was the original prompt. So you can see it's currently hard coded to this. But we can easily replace this, so I'll just delete this. And remember, at the very top, we are passing to this component the original guess. So I'll just go original guess, and then I want to get the prompt. Great. So if we keep scrolling down our screen, we can see that the last thing we're doing here is we're just controlling the width of the progress bar based on the similarity score. And you'll see what this is in just a sec once we test this out. And speaking of testing, let's go back to our app and see if the new functionality we just added works. So here we'll enter our prompt. This looks like a man playing the violin. We'll submit and our loading screen is working. Great. And then finally, after our similarity score is done being calculated, you can see that we get our score screen. And it looks like it's working all right. We can see on the left-hand side, we have our original prompt being displayed. And on the right-hand side, you can see that we have the guess I entered, as well as an image that was generated for my guess. And you can see that my similarity score was just under 55%. So this looks like it's working great. But let's try again. This time it looks like we have some dolphins jumping. So we'll just enter that. We'll submit, we get our loading screen, And in a short moment, we should get our score screen. And just as before, we can see that it's working. And this time we got an even lower similarity score. Perfect. I know that was a lot, but we're finally finished. Granted, we still had to write a small amount of code to get our front end working, but compared to if we were creating this from scratch, the lines of code we would have to write to get something like this running would be significantly more. And if you think about it for just a second, we never really had to write at any point a single line of UI code. We just used V0 to generate the different screens of our application for us, and we were able to import that into our project effortlessly. This is the beauty of using V0 for generating your user interfaces. And coupled with BuildShip and its low-code visual backend builder, which we can use to build powerful backend logic, it's obvious that these two tools should go hand in hand. This is no secret. If you made it this far in the video, then you saw for yourself how in just a few minutes we were able to build the entire game logic of our game using BuildShip's visual backend builder. And we didn't have to write a single line of code. How amazing is that? And anything that you see here is fully customizable. If you want to add your own twist to it, you can do that. You can use any of the existing BuildShip's node to extend the gameplay. For example, you might want to keep track of scores in a database, so you can use the BuildShip database nodes. Or if you're not able to find what you want to do, then you can just use BuildShip's generate with AI feature. All you need to do is describe the functionality you're looking for, and you can generate it with AI. It's that easy. Hopefully you made it this far into the video, because if you did, then you're now ready to unleash all your ideas by using V0 for generating your front end and BuildShip for generating your business logic or whatever backend logic you want. And as always, everything that we build today, you'll be able to find as a template in our templates library. And if you found this interesting, then don't forget, we're putting out amazing content like this regularly. So make sure you subscribe to our YouTube channel so that you don't miss out on any of this content. That's all we have for today. See you in the next one.